Right, guys. Thank you all for coming here. My name is Alex, and I'm going to walk you through the ENS protocol today. Um, I want to start to briefly remind you what ENS actually is. It's a decentralized name service deployed on Ethereum. So what does it mean? I think most of you are familiar with DNS. So if you're entering Google in your address bar, your browser is going to the DNS service, asks what the IP the Google server is connected to, and then fetches the data from that particular IP. Why? Because humans are bad in remembering cryptic names or addresses. Like IP address is hard to remember, so is their address on the blockchain. ENS has the same purpose. It links a domain name that is human friendly to read to an cryptic blockchain address. So for example, vitalik.eth can be resolved to this particular address, which is the address Vitalik itself controls. As I said, it's completely centralized name service and it's deployed on Ethereum mainnet, so it contains or is built with Ethereum smart contracts. And today we learn which component this protocol contains and how these smart contracts are look like. At very first, the pure base protocol consists of two kind of contracts. The first is the ENS registry contract that links a domain name to an owner and the particular resolver, and the resolver contract, which you can use to resolve certain informations like names or addresses or like various other features. And there are registrars which are helping with the government of subdomains, for example. We are starting with the registry. What is the ENS registry? That's actually the core contract of the protocol. It's a very simple contract we will see soon. It maintains a list of domains. So as I said, for example, it maintains a relation that vitalik.eth it belongs to a certain address. It also keeps track of their resolvers and the TTL, the total time of live. It can be used for caching. So if you want to tell the client that it's sufficient to just fetch information about the domain for, let's say, an hour, you can tell them by setting a TTL. Also, there is like set approval for all mechanism. Let's say you can entitle addresses to do actions on your behalf, and you can manage subdomains. Subdomains are actually really important because I think what you know, everything is a subdomain. Like, for example, if you're, I think almost everyone who has an ENS domain, a .eth domain, and your .eth domain is actually a subdomain of the .eth namespace. The registry don't necessarily have to be used for the .eth domains, which I think everyone thinks about when hearing ENS. You can use the registry for every other domain. And if we look at the ENS contract, you're going to see it's quite simple. You have here the mapping I mentioned, which stores the relation between the owner and the record. The record returns the address of the owner, the resolver, and the time to live. And the operator that is used for the allowance. So you can entitle an operator, and this address can call methods on the contract on your behalf then. We got a modifier that is checking that the message sender is either an owner of the record or was entitled by the operator. And that's pretty much it. Then you have like set getters and setter functions for the particular fields. For example, you can set a new owner, which is doing not much, like it assigns as you would expect a new owner in mapping and emits an event. And that's pretty much it. That's the bytes 30. Construct is like we're talking about ENS names, and I think most of you are expecting an ENS name as a string. Like my name, for example, is alex245.eth is a string. Why are we using the bytes 30 strings on shape? Um, so the normalized UTS for this string of your ENS name is basically just to ensure that sensitivity doesn't matter anymore, and that is the reason why you often see bytes 32 node. It is this name, and so we bytes 32 string way easier than string. So I think it's an interesting pattern where strings of your are challenged to process strings. Maybe you know now can access this created that instrument. But the owner can set response to it doesn't necessarily have to be Ethereum, it can also provide your coin address or so. When you build something like who's the owner of the domain, you always have to do the reverse record because the resolver can set the value he wants to. The ENS resolver comes with an API resolver which can return a smart contract API. So if you want to get your smart contract in ENS domain, you can use the API resolver to resolve this particular API address I've talked to. That content hash, you can link your ENS domain to an IPFS website. Like, for example, you want to store, I don't know, your profile picture IPFS, you might use the content hash resolver, and there are other resolvers as well. I think all of them are pretty clear. I think one resolver that's worth looking at in particular is the text resolver, because you can store arbitrary data in form of key value pairs. So that might be useful if you're building a dApp and you want to enable the user to upload a profile for your app. You might use the text resolver, set a key unique to your application, and you might add this. it's also pretty simple. So they call it profile, basically like every functionality is implementing it by hand. I like this because it separates the concerns pretty well. Yeah, it's every structure, and orchestrated inheritance. So here is for authorization, so you can also authorize someone else to execute transactions on your behalf, and you can do a multi-core if you want to update multiple fields at once.
I was just a
Function.
moment to make. I was looking into one
That's
of.
the ENS resolver. Also, I
Okay,
just two
I was
concepts,
just
pretty
looking
basic
into
concepts here. Has anyone
the.
questions regarding the resolver or the registry? I'll have to go ahead. So I've registry is not just the lead namespace, but I can consider every domain you want to it. But by far it's a domain, top level domain. I think I'm thinking about the thinking about ENS. So I want to show you more how this study namespace is managed and what does it mean, or how the registry or the other contracts are fitting in to build a system like ENS. So as I said, there are like roughly 2.8 million ETH subdomains registered yet, and those subdomains have to be managed. And this is the job of the register contract. So basically, if you go to the ENS registry and look for the .eth domain, the ENS registry will return the address that is the registered contract, and you will use this contract if you want to mint a .eth domain. .eth domains are ESC 721 contracts, so you can transfer them. I think most of you know that you can trade your ENS domain on OpenSea, and there are people that are trying to mint ENS domains for like the purpose of selling them to people that are appreciate value. Also, ENS domains are type. So I think 2 years per default or so. After that, you pay ENS again in order to use your domain, your domain. Otherwise, someone else could claim. Um, how does the register contract look like? It's a little bit more complex, but I will show you guys how it works either. As I said, it's used to govern the .ens subdomain, and it's the owner of the ETH namespace. So it collects the fees for the ENS DAO. So ENS basically lives from the revenue this register of ENS domains make. You can use this contract to register a new domain, to renew a new domain. That means to extend your new owner. You can buy fees to yeah, you can buy fees to uh, extend the expiration date of the domain. You can also reclaim the domain that's being used if you want to, if you bought the domain on the second market and tell the top level registry that you are the owner of the address now. Commit means you can protect running. We will see how this works later. And the year is 21. So I would say we will look how this all works in practice. So let's see. We're connected there. And if we go to adapt, we can use we're girl here, and I don't know my new fancy ENS name, whatever. we try to mint this, you can see what I just mentioned. You can set arbitrary number of years. I think there's no limit. So if you want to register your domain for 1,000 years and you're willing to pay like 2.78, you can do so. But for now, we go with 1 year. And then we were able to start the purchasing process. So, and here comes the commit and end. So, if we would have no commit functionality, someone could easily front run us by picking our transaction from the mempool and using a slightly higher gas fee to steal our new name. So we have to actually do 2 transactions in order to mint any name. And the first is to make this commit. So what's happened here? If you um, if you make a commit, you're making a hash of the domain you intend to buy, a age, and I think a random number. And so the contract ensures that even though you would be the front runner likely to not have made your commit, you can still mint the domain without being in danger of being front run. All right. So let's wait until our commit transaction went through. Sometimes it takes a while to girly, if it's girly. Bro. Think yeah, we there, and I think they use like time mode of 60 seconds. I don't know if what they're doing. This thing is also a protection of front running, but after the timeout, you can register your actual domain. So what's happening here is also not that complex. The contract checks if you are if the token you're about to register is available or someone else was claiming this token. I think this grace period is actually why you need time to that. If it existed before, you have to burn it, otherwise you can directly mint it. If you mint it, the contract will mint you your C21 token that you can trade open later, and it sets you as a subnode owner. So if you remember, our registry offers us the possibility to set a subnode owner, and that's what the registry does here, because it's the owner of the parent namespace. The register contract says, all right, my fancy ENS domain is becoming a subdomain of .eth. And that's how you can use the .eth namespace, although it's being owned by someone else. And that's pretty much it. They emitted the event that you're now registered that name and you're good. Then you can use the ENS name. Let's do it. And that's it. I got my name. And if you remember our resolvers, they are if I would have used them, I could use the ENS front name, front end to look like, for example, what the content dish would look like, or what the API would look like. And you can see the resolver contract. I could update this, but if we go to you see that it'll be as public resolver contract, so it's their default resolver we're going to use. And that's all I have for you for today. So if you like the presentation, I would be happy. Otherwise, if you have any question, please reach out to me. You can send me a message on Twitter or on Discord. I would be happy to answer further questions now. Otherwise,